Good day. Welcome to our MicroThermo Alliance training. In this training session, we will go over the features and benefits of MicroThermo Alliance, Echelon Protocol and Echelon Hardwired Network, onboard reports, navigation of MicroThermo Alliance, and finally, the hardware required for an installation of MicroThermo. Okay, let's get started. He's going to be concentrating on being a field integrator for MicroThermo. I don't know if you were aware of that, so please make that note. Also, Jason Alcorn is one of our integrators. Troy Miller is an integrator. Evan Ashow from the West Coast is an integrator. Carl Krasnecki also does integration, but really he is the integration manager for the United States. And a very important number for you to have is the MT support. If you are assisting an end user or a contractor and you really get stuck, please have this number 888-920-6284. Looks like Nathan is having trouble joining us. Nathan, if you successfully join us, please let us know that you're in. Okay, so guys, you know the deal with Parker. It's many different parts of the organization. And
hey, Charlie, just really quick.
Yes.
It looks like Nathaniel's in, but he's still muted.
Okay.
There we go.
Finally. Oh my gosh, sorry about that.
All right,
welcome.
You're with us,
Nathaniel.
Nathaniel.
My backup laptop.
I'm sorry, say again.
I had to pull up my backup laptop.
Oh my goodness. What happened? Security settings were
Three.
Say again?
I have 1, 2, 3, 4, 4 screens in front of me now.
All right. Okay, here we go. All right, so we were waiting as long as we could. We're ready to take off. Do you prefer Nathan or Nathaniel?
Nate. Nate is the best.
Okay,
Thank
Nate. Nate, at any moment, if you have a question at all, please bring it to my attention so that we don't get too far down the road and maybe lose a chance for me to address your question. Long story short, Parker, a very large corporation made up of many different companies and groups. But what happened about 14 years ago, give or take, Parker acquired Sporlin, and about 10 years ago, they acquired MicroThermo. The idea behind that acquisition was to take Sporlin, who was a leader in refrigeration controls in both large, medium, and small valves and controls, mix that together with Parker and Flowcon, and then finally with the acquisition of MicroThermo, now we have an organization where both on the mechanical side and on the electronic or the computer control side, we can control everything that you need to control when it comes to any type of facility or supermarket application. So that was the idea behind that. And when you're dealing with myself, Nate, or even David or John, please know that you have someone to help you that has the background of both the mechanical and the controls technologies. So when there is a question, we don't wind up at a job with everybody pointing the fingers at someone because, nope, that's the electrician, no, that's the mechanical guy, no, that's the valve guy. That was the whole idea of putting together this one business group. So what is MicroThermo? MicroThermo is a state-of-the-art facility management platform. We do control, monitoring, information, but we really shine on the information part, the historical graphing, and the data. So we're more than just simple control or monitoring. MicroThermo is a true management tool, and it's all done with a Windows graphical format. So if you're comfortable with Windows, if you know how to cut, paste, drag, drop, select, zoom, you already know intuitively how to navigate your way through MicroThermo. So the concept when MicroThermo was brought to the industry over 25 years ago, they wanted to take a look at any type of facility or any type of supermarket application and who has to touch that platform. Is it the installation and commissioning team, monitoring, retail, food quality, safety, finance, energy, operation, engineering, service and maintenance, etc.? And we try to put something in the platform that would be useful and helpful to anyone who has to interact with MicroThermo. What do we do? Well, our main sandbox obviously is supermarkets. We have over 275 CO2 installations in North America, most of them being transcritical CO2. We also do frozen and refrigerated warehouses. We do ice skating rings, marine refrigeration, processing and prep facility, ice cream and dairy plants, pharmaceutical process and storage. I also did a couple of projects that were actually DNA laboratories. And when we take a look at whatever the facility is, we say, okay, what are the goals and the needs of that facility? Well, we want to reduce food, or we'll say product loss, improve food or product quality. We want to extend the product shelf life. We want to optimize the temperature control for not only that product, but the actual environment or envelope that it's in. We want to reduce service costs, reduce energy costs, reduce management costs, reduce facility costs, and the whole idea, obviously, is to increase profitability. Now, that's from the facility or end user, but we know that they have contractors that work with them, and we wanted to make sure that the contractor has useful tools within MicroThermo to help them. So, bless you, real-time smart alarm notification by text or email or both. The 5 W's, which I'll talk about later, but there's always at the top of the landing screen, the most current notifications, who, why, what, where, when, of what is happening in your system. That's always there real time. We offer virtual remote troubleshooting. That's exactly the same as if you were in the store or in the facility and you were standing at the keyboard and screen. You get the same exact experience if you're on your phone, if you're on your tablet, if you're on your desktop or laptop. You see the same exact thing you would see as if you were in the store. Now, in that is remote graphing and graphing analysis. We keep up to 5 years of system history, depend upon the sampling size. So if we sample more, that might trend down to about 3 years. If our sampling's a little slower, you get at least 5 years of system history. And that history is a rolling history, if you know what I mean. What I mean by that is, as we add new history, we drop the older history. So there's a 5-year window that's moving forward. We do that so that we don't overload the memory on the system. But generally, it's much more than you get with other systems out there that might give you a couple of weeks or a month at best. It allows you to do remote system modification, set point changes, superheat suction pressure, defrost schedule changes, overriding a compressor or overriding a fan. Electronic service log, so that it's not just the oil-soaked loose leaf binder in the mechanical room. We always tell people use the electronic service log so that you can tell what someone did remotely. You don't actually have to be there. The alarm triage report, which I'll talk about. And again, same type of goals. We want to reduce labor, reduce service costs, reduce management costs, and increase profitability. The idea being, before you have to roll a truck at 2 o'clock in the morning, you can probably solve the problem right from your home or your shop without having to put a truck on the road. So with facility management, we say if you don't see it, if you don't measure it, if you don't analyze it, then you truly cannot manage it. So I'm going to go over some of the system tools and reports that I think are very helpful. I'm so familiar with this, I do tend to move quickly. If I am going too quickly, please at any time tell me to stop and slow down and get your question out there. So the first thing I want to tell you is there are 2 things going on when you look at MicroThermo. There's the front end and the back end. The front end is the MicroThermo Alliance software platform that does all of the control or monitoring. The back end is the actual Windows operating system. So we use either Windows 7, or since Windows 7 is no longer supported by Microsoft, most of our customers are upgrading to Windows 10. So we have the operating system in the background, or the back end, and what that is that's the control of the physical computer itself. And we have the log available for you, and the log is there so that you know what is happening in the back end. Did someone try to log in? Did an unauthorized user try to log in? Was there a power failure? Was there anything going wrong with the system itself? So this log is there. I suggest that you look at it from time to time. And if you notice up here in the right, you can customize it. You can look at it for a day. You can look at it for a week. You could look at it for a month and judge the health of the operating system that's occurring in the background or in the back end. Now, what I did is I added this star to the slide. There is a bar at the top, and you can find these reports that I'm talking about either under events or under reports. We won't have the ability to log into a system today, so I wanted to show you where you would find that, either under events or under reports. So the report that I'm talking about right now is called Changes Made by Users. And again, for either the end user or the supermarket or for the contractor, what this does, it shows you for either 3 to 5 years every single change that is made into the system. Did somebody change a superheat setting? Did somebody change a target set point? Did somebody change a temperature set point? Did somebody drop out a compressor? All of that is kept in the system for you to investigate. And again, as with the other report, looking at the lower left-hand side here, if you wanted to do it for a day, a week, a month, or a year, you can focus in. You can look at changes, you can look at maintenance, you can look at both. Also, you can look at a specific user if you want, or you can look at a specific component within the system. So it allows you to customize it. So again, the date and time, who was the user, what was the system they were working on, what was the component, was it a plug-in, was it a piece of equipment, etc., and what was the description of the change that they made. What has happened with other systems and other technologies, people use generic passwords, which is a very bad thing. We ask our users, please do not do that, because we want the security to be, if you go into MicroThermo, your fingerprints or your footprints are left in there, so there's no question at all who did what in the system. Secondly, we want you to make this system or your store as efficient as possible. Once you do that, we want you to lock it down, and we don't want you to allow every buddy and their brother to go in there and make changes to the system, okay? And if they do, here's where you can find that. I'll take a moment and step back and see if there are any questions at this point. All right, seeing none, I'll move on. Another report is called Alarm Acknowledgement or Acknowledge Events. We call alarms events. And on that report, same thing, you can narrow in the time period you're looking to do. Again, 1 day, 1 week, 1 month, 1 year. And what it does is it tells you the priority of the event, high, medium, okay, or just notification, the date and time, what was the source of the alarm, a description, if somebody acknowledged it, who did the acknowledging, at what date and time, and what subsystem were they working in. Again, also you can pick up the pieces and you're not looking for a needle in a haystack. This is my favorite report, guys. If I'm going to join you for a troubleshoot, this is the first thing that I'm going to dump to the screen. Acknowledged event statistics. What this does is, I call it the triage. The real name is acknowledged event statistics. And what it does is you can, again, by date and time, you can make this a day, a week, a month, a year, whatever. But what it does, it aggregates all of those events. So you're truly not looking for a needle in a haystack. It groups it by how many events, how many recalls, and how many total hours. So Nate, if somebody from one of your stores calls and said, yikes, we're having problems with temperature, my freezer and cooler, I could never keep the temperature where I need to be. If you pull this report and you go, well, look at this here, freezer door ajar, 59 alarms for 57 hours, dairy cooler, door ajar 47 times for 46 hours, it's quite possible that that's what's causing the temperature problem, because when they stack the product into the freezer or the cooler, they're putting a U-boat cart and propping the door open, and to make it easy, they're just leaving the door open for 10, 15, 20, 30, 45 minutes at a time. And of course, that's causing you, A, to have a temperature point that drifts up, and B, it's triggering an alarm. Now, at this point, let me tell you how we do alarms so that there is no confusion. You'll see it in a later slide. We ask the end user to give us their alarm specifications. Why do we do that? Because certain product, certain fixtures have different alarms. So it might be, for some product, a half hour before an alarm gets triggered. Other product, it might be an hour. Other product, it might be an hour and a half. So the first trip you have is the alarm itself. Whatever you tell us to do. A half hour, 1 hour, 1.5 hours. The next thing is called the recall. What do we mean by that? If the store manager or the contractor acknowledges the alarm to make it go away, well, we just don't want somebody to put a Band-Aid on it and walk away. So let's just say it's prime cut meat and the temperature's too high, and all that technician does is alarm silence, but doesn't take care of the problem. Now, if you have a recall on that initial alarm of 30 minutes, that means if that has not come back to proper temperature within the 30-minute recall period, bang, we're going to send out another alarm, okay? So we're going to get a red light on that. We're going to send out an email or a text message, and that is called a recall. So if you acknowledge an alarm, but the condition does not improve, and it's just a simple acknowledgement, then the alarm is going to come back and it's going to pester you or nag you to say, hey, you didn't solve this. You still have an alarm problem in the system. Any questions about that? We're different in the way we do alarms. We don't want them to just magically disappear because somebody shut it off. They can silence it or they can acknowledge it, but if the problem is not solved, it's going to recall and another alarm is going to be generated. Okay? I hope that was clear. Any questions on that?
Where do you pull up the acknowledged event statistics?
Okay, let me back up a screen. You would get it from here under events is where if I can, I wasn't able to get permission, Nate, from a customer, and I like never to go into somebody's store without permission. But under here, we have acknowledged events and then acknowledged event statistics. So you click on that and then you get a drop down and it asks you, what are you looking for? And the first one is acknowledged events. That's everything. I mean, every bloody thing that's happened. I always like the one at the end of the list, Nate, and that's acknowledged event statistics. And that's this report right here. Okay. Okay, moving on. The other tool that we have on board that you can find in either in the tool or icon bar or right within the node is the trend graph tool. This is extremely useful, especially if you have You know, we all have one of those jobs where for whatever reason, we've got a fixture that just doesn't behave. And what that allows you to do, it is allows you on one screen to create a total of 7 graphs. So look what this technician has done on this screen that I borrowed. They've saved discharge pressure for rack A. This is a CO2, gas cooler outlet pressure for rack A. What are my oil demands for rack A? And what is my oil level switch for rack A? 0 being off, 1 being calling for it. And what we do with MicroThermo is you can then save this. When you click OK, it'll ask you, do you want to save this configuration? And we suggest save it, give it a name, because guess what? 2 days from now, 2 months from now, 2 years from now, you can come back and you can pull up this configuration without having to create it again. And guess what? By using this back button, you can start going back in history and take a look at these set points and see how they've been behaving over the last 2 days or over the last 2 weeks. And we have the icon for trend graphs in several different locations where we thought, okay, put it in the case controller, put it here, put it in the toolbar, just so wherever you are navigating, you can find an icon for trend graphs, and you can start pulling trend graphs and keep yourself a little library on the job for troubleshooting purposes. Any questions? Okay. All right, moving on. So MicroThermo is graphic user interface. And as I said earlier, if you're familiar with Windows, you can navigate your way through MicroThermo. So whether you want to be in a process view, whether you want to be in HVAC, whether we are monitoring your energy consumption with watt nodes, controlling your lighting, controlling your HVAC, controlling self-generation at the job, controlling and monitoring VFD, temperature monitoring, refrigeration, leak detection, and anything else you can think of. If there is a mechanical or electrical system you want to control or monitor, we can do it through MicroThermo. Therefore, you just have one front end that you have to interrogate, and then you're just bouncing from window to window to window. Just as easy as that. So MicroThermo Alliance, it's all about accountability, traceability, and security. Access accountability, we recommend strongly everybody gets an individual username and individual password. Please do not do generic. Within that, an individual can be given different levels of access. We can make some people have look only but don't touch, and we can turn things on or off depending upon the competency of the technician, and if the end user has warm air guys in the job for HVAC units and then has refrigeration contractors for the rack and temperature management, we can set it up so the hot air guys can only do the rooftops and the refrigeration guys can only do the rack and the temperature monitoring, and they cannot touch the equipment that they have no permission to do so. And again, the whole thing is we want to get it locked down as energy efficient, as tight as possible, and we don't want it to degrade over time. And finally, it's all about eliminating unauthorized set points, set point changes, component jump out, or device disabling. So it is individual, intelligent, distributed control. It's Windows-based. You can have 8 workstations per store. That means a keyboard and a screen and a mouse. We can retain history for up to a little over 5 years. We talked about CO2 control. Everything is integrated, so you have one front end. It's all icon-based, so it's management at a glance. It's customizable. If you have something you want us to control and you want a certain look, we can do that for you. And finally, it's open standard. LON works as far as communication protocol is concerned, and as far as the network is concerned, it's a free topology. Why did we choose Echelon 27, 28 years ago? Because it is a worldwide standard. It is used all over the world in all different types of control beyond supermarket refrigeration. I won't bore you by reading this slide, but it is robust, it is redundant, and it's very trustworthy. That's why we have stuck with Echelon and LawnWorks. We're going to talk about the LawnWorks side, which is the communication protocol, and I'm also going to talk about the actual physical network, because it's very important to understand, because we are different. I'm going to use other words. There's RDM out there, there's Danfoss out there, there's Novar out there, there's CPC out there, and we are different. In that list of names that I gave you, some of them use the word Echelon and lawn. It is not the same lawn that we use. We actually pay a royalty to Echelon, and the reason we do that is because the true Echelon is a platform that enables manufacturers to add distributed intelligence and communication capabilities to their products. The big takeaway from this is I've got a rack made in Canada. I've got cases made in the United States. I got a VFD coming from Asia. I've got a leak detection system that I have coming from Scandinavia. As long as all of those are Echelon communication and communicate on an Echelon network, you have to promise that you will be able to integrate all of those systems and products together. No motherboards, no daughter boards, no licenses, no license fee. You have to guarantee that they're interoperable and they're plug and play, and they will all work and communicate and cooperate together. Does anybody have a question at all? Trust me when I tell you, with other systems, oh yeah, we can make that work, but there's a charge for that. We can make that work, but you need a motherboard or a daughter board. Oh, and by the way, there's a charge for that. The whole idea with open Echelon is that it's got to be plug and play, no matter where the product or where the software comes from, and it's got to be able to integrate together and work together. Any questions at all before I move forward? Okay, so again, I won't bore you to tears, but we have the LawnWorks part of it, and I'll just shortcut it. Just think of it as a thesaurus, a dictionary, or a common terms that are used all over the world. So the communication protocol is Lawn Talk. We have network variables. We call them snippets. We have user network variables that might be custom, UNVTs. Standard configuration parameters, skip it. Or if it's custom, user configuration parameters. And in terms of control, everything is called a node, and we are either using standard objects such as sensors, actuators, etc., and standard functional profiles, HVAC, lighting, refrigeration, VFD. Again, the takeaway from this slide, it is a common language, it is a common dictionary. We're all using the same terminology, so there is no problem when you're using a LAN device from another manufacturer halfway around the world. And when we're talking about the communication and network, what we're trying to do is we're trying to reduce the installation cost, less wiring, less labor. We want to be able to reconfigure logically rather than physically whenever possible. And again, it's for improved performance and reliability. We take the system tasks and we distribute them across many different nodes so that, God forbid, if one node fails, the overall system stability is not affected and everything else If we have 500 nodes in the store and one of them gets smoked by a spike or high voltage or gets drowned in water, it's not going to take the network and the other nodes down. And again, easier integration of different systems achieved through interoperability, no matter where that device comes from. So other modalities that are out there are using a centralized control. We are distributed intelligent control. So we call our microcomputers nodes or smart nodes, and we put them wherever they need to be throughout the store or the facility. The other modality, you have a master controller that makes every single bloody decision. We have a series of inputs and output boards out there. They are not smart boards. They take information from the sensor, they send it to the controller has to make a decision, it sends it to the output boards, and the output boards take action. We, again, use a series of nodes, smart nodes, on an echelon network, and once we program these nodes, they become self-operating, okay? They do not require a master controller to operate. Once they're programmed and integrated, they are self-operating. Any questions? So another way of looking at it, instead of having one master controller controlling everything that's in the system, the little green dots that are on the screen here, they are representative of a smart node. And once that smart node is put in a condenser, it knows what its job is. Once it's put in a rooftop, it knows what its job is. If it's on the rack somewhere and we program it and integrate it, it knows what its job is. It does not need a centralized controller to operate. It is self-operating. Now I'm going to talk about the network, because that is extremely important. We use...
Hey, Charlie.
Yes, yes, sir.
Before we move on, so you mentioned that if a node goes down, the overall system integrity isn't compromised. How would that be in a centralized control system?
In other control systems, it is required to be a true daisy chain in the network, David. And what happens is, from the first board to the 500th board, it has to be one consistent, let's say 485 network from start to finish. If something happens halfway through that network, it's quite likely to take down then, and you'll lose everything downstream of where you had that either network breach or that board failure, and then everything else that's in series from down there, because it's a one gigantic daisy chain, you may lose that.
Okay.
Okay. The type of we're free topology. The type I try to talk our people into using is the star. I think the star is the best. Was there another question out there? I think I heard another voice. Okay. All right. So we're echelon FTT10 78K as far as the speed is concerned. We promote either star or free topology. It allows you 64 nodes, and each network segments can be 500 meters. That's roughly 1,640 feet. So what do we use differently? If you're not familiar with it, a lot of other modalities use a light gauge, I'm going to say 22 or 24 communication cable with a foil shield or a drain wire shield. That is a big no-no for echelon. You may want to write this down. This is a spec by echelon. It's 2-wire, twisted pair, no shield. And whether it is the main drop or whether it is node-to-node communication, the spec is Belden 16 gauge, and the Belden model number for echelon is 8471. I suggest not varying from this, even if the contractor says, oh, my company that I deal with has a cable and they say it's echelon enabled. I personally have been burned by that a couple of times because it is the capacitance, it is the impedance, it is the resistance, it's how many twists per foot. All of that is in this spec right here. And any little change in either resistance, capacitance, impedance, or whatnot is going to affect the stability and the strength of the network. So please, we ask you to abide by the echelon requirement here. And when it comes to MicroThermo, please use Belden 16 gauge 8471. Now, in terms of layout, this is the network layout. We have the backbone, or some people call this the near side, and then we have network segments, which is the far side. Let me show you an actual drawing of what a larger supermarket would look like. It starts with a Windows 10 industrial computer. This is not a main controller. The main backup store profile resides there. The communication to the outside world emanates from this. But once I program each one of these circles, which is representative of a smart node, okay, it does not need this main brain, okay? These are self-operating once they're fully controlled. So the back end, or the backbone of the system, is the data logger or industrial computer. We have an alarm node. On the alarm node is a real-time clock, and then 2 schedulers. So in terms of synchronization, the nodes synchronize to the time clock in the data logger, simply for synchronization. If anything should happen to the data logger, they then sync to the real-time clock on the alarm node. If anything should happen to the alarm node, then each individual node has its own countdown clock. To be truthful, if that should happen, you would lose some synchronization if they're using their own internal countdown clock, but at least they will have some type of clock to refer to. So you have one level, second level of redundancy, and then your final redundancy is the countdown clock that resides on the smart node. Now, each communication network segment usually will start with a router, and after the router, we can go up to 64 simple nodes or 50 compound nodes. And check this out, if you still need a network to be bigger, after the router and after the 64 or 50 nodes, I can add a repeater, and I can add another 50 or 64 nodes downstream of that, and another 1,600 feet. Any questions on that? So the MicroThermo network, the echelon network, can be huge. I can have 2 channels, I can have 10 channels, I can have 20 channels if you want me to do that, okay? I can have a channel for rack A, a channel for rack B, and a channel for rack C. Another one for the HVAC system, another one for the lighting system, another one for energy management, et cetera, et cetera. Now, let me tell you one thing that is different about our network. You see this black box here, 53 ohms, and this black box here, 53 ohms, 53, 53, 53. Someone asked a question before. These are not end-of-line terminators. That's what you use in a system that is a daisy chain. The resistor has to be at the end of line. What we do is we put a 53 ohm on the backbone, and for every network segment or channel, I'd like to call them, we put another 53 ohm somewhere close to the geographic middle of the network. And what we're doing then is making sure that the backbone and every network channel are both balanced. They both have an intrinsic resistance of 53 ohms. That acts as a shock absorber and helps the system to communicate. All right. Let me just let this marinate for a while, because I will tell you, John, Dave, and Nate, anybody's system, whether it's us, Danfoss, or anybody else, CPC, MicroThermo, network is key. If you have a lousy network, if you have poor installation, you're going to have poor system performance. Network is important. Stay on top of your network electrician and make sure they do the job correctly. I think I heard a question there. Go ahead.
Yeah, hey Charlie, this is David. What's the difference between a simple and a compound node?
Oh, good question. I'll give you an example when I get to the case controller. If you take the lid off a case controller, you will actually see two nodes in one, Dave, okay? And our alarm node, as a matter of fact, is a compound node. The alarm node, and then you have a micro node, the real-time clock, plus two other micro nodes on top of it. So in the alarm node, you have 1, 2, 3, 4 nodes in one. So this would be a compound node, and the case controller is also a compound node. You'll actually see two green boards inside of one enclosure, and we call it a compound node for lack of a better term, but because you have many nodes communication, that creates more network traffic on the system. So it's all about a network traffic, and we don't want a traffic jam. So if you have, for instance, 50 case on this rack here, up here, David, if you had 50 case controllers, that's the theoretical maximum. If they were simple nodes like a 508, you could put 63 or 64 nodes because they're single nodes. And again, it's all about the network traffic. There's a lot of communication flying back and forth. And if we put too much communication on the network segment, it's like an interstate being in a traffic jam, and then you start to get overloaded. Okay?
Okay. Thanks.
All right. Any other questions? It's very important that you have the contractor check every segment. Check the backbone, check A, check B, check C, check D. We don't want the resistance to be any lower than 53, nor do we want it any higher than 58. If you do that, you will have a solid rock star network that'll be so fast and so stable. And then in that little bar that I showed you earlier in the talk, I think Nate asked about that, we also have a network analyzer. And we always tell our integrators, check the network before you leave the job. In Echelon, if you have a network rating of 25 or 30, it's considered good. We actually want our network to check in the lower single digits, a 2, a 3, a 5. We want that number to get as close to 0 as possible. When you get close to 0 in the network analyzer, that means you have a network where the nodes are not clogging up with over communication. That means the electrician did the physical wiring properly, and the better the network, the more pleased you're going to be with the MicroThermo. And again, that's why we use the 16 gauge wire, which is a darn heavy wire for communication, but you have more surface area, and that allows more electrons to flow back and forth and gives you rock solid. Now, Dave, I think you asked me a question. So let's say if you're looking at rack A right here, and this controller right here, CKT number 1, let's just say somebody spills water or shocks it somehow. Just because this one node goes offline, it is not going to take this network channel down, and it is not going to take the network down. Okay? Any questions at all? Let me see if I can go ahead to a slide that I may have hidden. Let me go to this slide.
Charlie.
Yes.
I was just going to say, in that case where that one unit went down, the communication for all the units downstream of that is still up and running, yeah? Because of the way it's chained, like, I guess that's what you're showing us right now, huh?
Exactly right. I wanted to get ahead of myself. I went down to a further slide. Back in the day, we had a 4-lug, and we've eliminated that on the MT700. It's only a 2-lug. And the reason we do this, Dave, and everybody on the phone, whether it's black and red or black and white, okay, in the United States, the echelon wire is black and white. We actually physically twist the 2 blacks together, and we physically twist the 2 whites together. We land them on the lug. When we do that, it's as if there is no break in the black wire and no break in the white wire. You with me on that? Okay. And then we lug them down tight. And the reason we do that is because even if this board gets smoked, Dave, or we actually unplug the network wire, we have not taken out all of the other nodes downstream. That's the beauty of 16 gauge and wiring it like this. And I don't want to beat a dead horse, but trust me when I tell you, I am a pain in the butt when we do my pre-startup visit about a month before we turn the store on, because I promise you, if you make your electrician or subcontractor do the network right, you're going to be so pleased with the way MicroThermo is going to work. But that goes for any system. If you have bad network wiring, I don't care whose system it is, it's going to take the system down and bog it down if you have bad network wiring. Okay? But the echelon network, if it is wired and done as I've described to you, it is super solid, super stable, and very robust. Any questions at all? So again, it is not a network termination. It is not an end of the line resistor. What we're doing is balancing 53 ohms, 53, 53, 53, 53, and we want that envelope to be somewhere no lower than 53, no higher than 58. If it's lower than 53, you might have a breach somewhere. If it's higher, if you got 75, 80, or 100, you probably have a wire that's skinned somewhere, or you've got a board that's grounded, and that's why my resistance is too high. Again, this is something that should be done at pre-startup. The network should be tested before we try to fire everything up. Okay, so the echelon network starts with the guys call it a data logger. I'm an old timer. A data logger means something totally different to me. This is actually a Windows 10 industrial computer. And by that, I mean, it's not like the Dell computer you go down to Best Buy and purchase. That's got so much bloatware on it because it's a retail computer. The industrial computer only retains the exact guts that it needs to operate the MicroThermo front end. We don't have the stuff on there for gaming or all kinds of other nonsense on there because it's not needed. So it is an industrial computer. Only what we need to support the operating system is on there. No other programs, no other bloatware. Okay, so it starts with the industrial computer. The very next device is the USB echelon adapter. That plugs into the #1 echelon port or USB port. Let me correct myself. And you see this green plug right here, gentlemen? My black and white or black and red network starts right from there. That's the beginning of my echelon network. The very next device that I drop my wire to is this orange plug right here. So the data logger, the echelon card, and this right here, gentlemen, this is the alarm node. That's my backbone. Now, David, you asked a question. I think this slide hopefully will explain it a little bit better for me. Underneath, this is the base node right here. And then on a pedestal, this is the real-time clock. This is scheduler #1 and scheduler #2. This is a compound node. Now, I hope you can see this. Look where my cursor is. This is the service button This is the reset button. That's how I get a node onto the network. If you look very closely, you have a service button and you also have a reset. Service, reset, service, reset. So you have a node number 1, node number 2, node number 3, node number 4. So that's what we mean by a compound node. And I will tell you, gentlemen, when you look at a network analysis, this board, because all of the other nodes are syncing up to it, you will have 10,000, 15,000, 18,000 communication bits flying out. Don't get alarmed. That is normal for the alarm node, because every single node in the system, whether it's 100 nodes, 300 nodes, 500 nodes, is all syncing up to this real-time clock, okay? It's also got a watchdog in it, so you'll get a ton of communication coming out of the alarm node. That is not a problem. Any questions so far? I know I'm throwing a lot at you, but again, this is where it all starts. We already talked about this. If we're making a star, gentlemen, we always tell the contractors, do not use wire nuts. If you're going to do a star, which is what we prefer, our spec is to use a Wago connector, and they come in 1, 3, or 5. And what happens is your number 1 black and your number 1 red or white go in here, and then I can drop 4 other star segments out of that Wago connector. And once you lock that lever down, that lever is tight. And the beauty of a star is you can have a star and 300 feet later, you can start another star. Okay, so you can have a star after a star. That's what we mean by free topology. You can be as creative as you need to be and use the least wire, because think about this. If I have a daisy chain network, I go all the way down the west side of the store, I pick up all of the cases, then I have to come all the way back to the north side of the store, go to another aisle, pick up all of those cases, then I have to have a home run all the way back and pick up the next aisle, so on and so forth. You don't have to do that with a star topology. You can bring it to the middle of the store, and your spider or octopus, whatever you want to call it, you can go north, east, south, west, and pick up all of the parts of the store. From your beginning star point, you use much less wiring if you do that. And we always tell the contractor, make an as-built network drawing. And if you give us the as-built network drawing, we'll actually make a file and put it on the MicroThermo so you can look it up and see your as-built network wiring. So if you ever have to troubleshoot the network, we can actually save it and put that drawing on the MicroThermo platform for you. Any questions so far? We've gone an hour. At this point, I'd like to give you guys about a 10-minute break. Let's circle back in 10 minutes, and we'll go probably about another hour, and that'll be it for the day. Does that sound reasonable to everyone?
Sounds good, Charlie.
Okay.
Yeah.
So,
I just want to remind you, Charlie, that
I know you got to bug out. I got you.
Okay. Thanks.
Okay. So it's 1:33 right now. Let's round it off. Let's come back 1:45 and we'll finish up the class. Okay.
Okay, cool.
Okay.
Thank you.
Yep. Still there, Jonathan?
Yep, still here.
Okay, we'll about another 2 minutes. We'll get rolling.
Perfect.
Jonathan, so far
Trying to
so
knock
good.
down.
Jonathan, so far
Yeah.
so good.
Yeah, definitely. It helps to see it again, you know. I mean, we've watched your other trainings, but just kind of helped me to think it through a little more.
I prefer to be able to interact directly than to watch training, you know, on a screen. And what I'd like to do after this is set up another class for us. Well, I'll get permission. We'll log into a system and we'll go through the store.
Right, that'd be great.
Okay, I see Nate is back.
That's very useful. Yeah, being like doing interactive. That was my question. I was going to ask later too. That's why, because then I have access to my stores, right? And then while you're doing it in conjunction, I can go on my stores too. That's why.
Nate, do you do Team Viewer in your stores?
No, we use VPN.
Yeah, see, that's the problem. Most
Yeah.
people are using a VPN, and I've not found a stable way to go through VPN and do Zoom.
That's why, yeah.
That's the problem that we have. All right, so let's get back into it. Application of Alliance. All right, so this is the main landing screen for MicroThermo Alliance, and the takeaway here is we use a stop light. I would say in terms of how we want you to look at a system, you know, we use a stoplight analogy. So green is good, all systems are go. Yellow is caution. Red means that you have an event or an alarm that you need to take action on. So green is good, yellow is caution, red is a problem. The other colors that we use, if you see something where one of these dots here is either white or black, it either hasn't been integrated or it's lost its connection, physical connection to the network. Okay, so white or black of any of these dots, that's a problem. And then in terms of operating colors, we have orange, which indicates that that node is in defrost. And then the other color we use is a bright teal color, okay? And that shows you that that node or device has been put into override by someone, by a technician. Either the lights are in override, the electric expansion valves in override, the fans are in override, or if we turn a compressor off permanently, the compressor's in override, and we chose that bright teal blue so it stands out on the screen. Earlier in the class, I told you about the 5 W's. Was there a question?
Yes, can you repeat the color code again? I got teal, which is override. What was the other colors?
Okay, stoplight is the primary. So green, all systems are go. Yellow is caution. Red is bad. Okay, you got an alarm or an event. Okay, then Nate, if all of these green nodes here indicate a smart node. Okay, if any one of them either goes white or black, that means we've lost connection. Either it wasn't configured in the first place, or it's lost its physical connection to the network. And then if you see one of these nodes have an orange circle around it, that means that that node has put that fixture into defrost. Okay. Now, the 5 W's are always here, the most current. So what is the priority, the date and time? What is the event description? Who acknowledged it? What date and time? And what subsystem did the event come from? Again, the gold key here, that's your login. So when you hit the gold key in an operating system, a window comes up and you have to put your username and your password. Here is one place that you can find trend graphs. So by clicking on this icon here, you can start building a trend graph. And then up here, you have access, who can use the computer. subsystem, what mode are you in, the events that I talked about, the different reports that are on here, and I'll skip over to this one, network. That's where you'll find the ability to test the node or analyze the network. So when you click on these in an operating system, you'll actually get a drop down. And so far under network, it'll talk about the architecture. It'll give you a complete list of all of the nodes that are in the system, and you can run certain reports and tests out of network, okay? So you've got your tool and icon bar. You've got your menu bar, your events and alarm lists.
Yep.
Now on the left side here is your subsystems. So we might have the main floor view right here. We might have lighting. We might have energy. We might have security. So any subsystem that's in the store would drop down from the left here. The standards are refrigeration, lighting, and HVAC, all right? In the middle are your permission modes. You have overview, which is primarily look but don't touch. The next level up is maintenance, and the highest level is configuration, and your programming and integration palette shows up. In the maintenance view, okay, this palette does not show up. Schedules does show up, but not the programming palette. And in overview, this side of the screen is blank. The only thing that you can interact with is your floor plan view, all right? And remember, as I said earlier, whether you're in maintenance or configuration, we can split hairs inside and give different technician different capabilities or restrictions within that main. So just because you're given maintenance and you're Joe Smith, okay, Steve Thomas, your buddy, can have maintenance, but he may not have the same capabilities that you do. We can actually individualize the capabilities within those three permission modes. And then finally, your store view. So here's your main landing page, your floor plan, but you could have a rack A, you could have a rack B, rack C, you could have a chiller skid view, you could have a VFD view, what have you, okay? Any questions at all? So anywhere you need to go is just a point or a click away. And we say, once you get there, you drill down, you drill down, you drill down. Any questions? All right, so again, you're going from window to window. So whether it is the schedule for defrost, your 24/7 schedule, showing what goes into defrost when. Here's a ventilation custom program node. You can find those through traveling. You can also have a virtual view of your rack, or you could have a tabular view of your rack, and all of these are showing pressures, temperatures, set points, etc. Now, Nate, have you taken a look at some of yours? Which it seems to me that Canada used to mostly use the tabular view, but a lot of the new stores are going over to the virtual view, which we've been using for about 6 or 7 years in the United States. Have you been able to interrogate any of your stores, and what view are you using for the racks?
I think Nate's on some. I think he got
Oh, you got called away? Okay, good. I'll
off for a second.
Yep, not a problem. And then here is, this happens to be a Bacharach leak detector, guys, which is Echelon enabled. And when it's got an Echelon chip in it, we can program it and interrogate it right through the MicroThermo front end. Okay. So what's the first thing you might run into? You might run into an alarm situation, and the alarm shows up here. It also shows up here. If the alarm node is pictured on the landing page, it'll show up here. And then most importantly, the actual node itself will go red. If you want more information, you drill down. The first thing you do is you zoom in. And when you zoom in, you'll see the description of the case and what is the real-time temperature, 42.8 degrees. And if you want to drill down further, you click on it again, and then you get your process view. Whether it's a simple sensor view like this, or it's a case controller view, usually the process view will either be a temperature graph, or in the case of the situation with the case controller, you'll get what we call the process view for that device. And then you would hit the acknowledge button right here. A window is going to pop up, and you're going to have to put in there's a simple drop down of what action you took, write a short sentence of what you did, and then you must use your name and your password to acknowledge an alarm. And that's kept in the system for 5 years. So again, we keep track of anything that you do in the system. Now, what can we control? Suction group control, PID control for suction pressure.
Hey, Charlie.
Yes, sir.
Really quick, when somebody acknowledges that does clear the alarm unless you have that the recall.
Yeah, I wouldn't say clear it. It acknowledges it. Okay. So let me give you an example. You get an alarm. The alarm was caused because somebody left the door propped open with a couple of milk crates. All right. You acknowledge the alarm. You move the milk crates. You close the door. Under the acknowledgement, you put discovered dairy cooler door propped open, closed the door, reprimanded the employee. That temperature is going to be okay. So after the recall time, if everything is good, that's going to turn green, okay? If the problem is more than that, Dave, and closing the door doesn't solve the problem, the light is going to, that node, let me go back to the screen here. This node, once I acknowledge it, it's going to do a test. If everything is good, it's going to turn green. If it does the test and not everything is within parameters, that node is going to turn yellow. And it'll sit there for the recall period. And if the temperature remains bad and simply closing the door did not solve the problem, that's going to go back to red and it's going to trigger another alarm. Make sense?
Yeah, and the 4 alarms that I see, well, I see one alarm in the 5W
no,
section
Dave,
above.
Dave, great question. This is all the same alarm. So that right here is a visualization. Okay. This is a visualization of what's happening here. And this is a visualization because this particular person put the alarm node on here, and it's telling you that either you have a klaxon or you have a strobe blinking. Okay, a lot of supermarkets like to have a white strobe on the back wall. Some of them have a strobe with a siren in it. Most people don't use the siren anymore, but they'll have either a white light or a blue light that blinks. So what's happening here is number 1, meaning you only have one alarm. Okay, how is it being visualized? The icon. You also have a strobe going off, and this is the 5W that's active in telling you, okay, you have an event, SN number 5 is in an alarm mode. So that's a great question that you asked. This is not actually 4 different alarms. This is the visualization of one alarm.
Okay.
So the number here could be 2, could be 3, could be 4. If it's a store that's on startup and nothing, and we just turn the rack on, Dave, everything is going to be at high temperature and the wrong pressures. So you're probably going to have 178 in that box, okay? Because it's just startup. And, you know, you would acknowledge those alarms periodically because, you know, they're going to keep banging away until the store gets down to steady state, all right? But this is actually one alarm.
And then tell me again, if we don't have the floor plan up for the HVAC system, will it nevertheless show the alarm along the top?
Yes.
Or do we have to click over?
Yeah, so let's just say the supermarket is good. This would be green here, but let's say it's a dirty filter alarm, or let's say it is a compressor alarm that's not working in rooftop unit number 4, this here will be red. This will be green. This will be red, meaning that one of the subsystems has got a problem. You hit the arrow, you drop down, and you're going to see what subsystem has an alarm.
Okay, good.
All right, great question. Great question. Okay, in terms of compressor control, we always fail safe to the mechanical controls, but we always try to equalize the runtime. So if you've got a rack with 5 compressors, we want to exercise them equally. We don't want to make it all only pump 1 and pump 2 runs forever and 3, 4, and 5 sporadically come on. We want to spread the runtime out amongst the 5 compressors. That improves the lifetime of the compressor. And we try to use the least amount of compressors possible. We can support a VFD on every single compressor if that is the desire of the customer. We can support digital discus and digital scroll. This is a differentiator for us, guys. We have proof of running and X proof, or the inverse proof. What that means is you'll have a green light next to the compressor indicating, yep, I'm calling for the compressor to be on, and yes, it's running. So you'll get a green light that pops up. If the rack...
Hey, thanks, Charlie.
What's that?
Thank you for putting this on.
Not a problem. We'll circle back around, and maybe I'll try to see if I could get permission to log into a store, and we'll interrogate a store together, okay?
That would be great.
Okay,
Thanks
awesome.
again.
Take good care. All right, the opposite of that is what we call X-proof. And if the rack controller is saying, okay, compressor 3, you need to be off. Well, guess what? The contactors got arc welded together, and this pump never shuts off. We send another alarm out, which is called X-proof, which tells you that you have a compressor on runaway. And it should be off, but it continues to run. And then, believe it or not, if compressor number 3 goes on runaway, this controller here says, number 3 is always on. I'm going to make that my lead compressor, and then I'm going to shuffle the rest of these compressors and always know that this one is on runaway until a technician comes in and fixes it. It knows that automatically. Or if the compressor takes it offline, the technician takes it offline because the valve plates need to be changed, MicroThermo knows compressor number 3 is offline. It's not going to keep pinging it, asking it to run, because it knows that it's offline, okay? Condenser or gas cooler control, PID or sequential. We can do air cool, evaporative, fixed or variable speed, VFD. We can split on either outdoor temp or heat reclaim, and we have all kinds of floating head strategies. Circuit control, we control refrigeration, defrost, all types of defrost, hot gas, warm gas, cool gas, electric, off cycle, pulsing warm fluid, etc. And we can defrost terminate on either time or temperature. HVAC, we can do full HVAC control through Alliance. The only caveat is the rooftop unit has to be able to have an echelon chip in it. Many of the manufacturers, Aon, Carrier, Trane, York, you can order the unit echelon ready. And other manufacturers like Seasons 4, if you tell them that the store is going to be MicroThermo, they'll put a 504, 508, or 512 right inside the unit, and they use our actual smart node right in the HVAC unit, okay? And again, whether it's a rooftop air handler, dual path unit, a VAV, whatever, we can control it. If it's echelon enabled, we can do humidity or dew point control, depending upon what area in North America. If your energy provider says you must load shed, those are built in, and also heat reclaim is built in automatically. Use it if you like, or don't use it. It's there on the control node if you want to use it. Anti-sweat is another thing that we can do. And we can do the anti-sweat based on either the dew point calculation or the relative humidity. And again, built-in load shedding function is there for the anti-sweat control. Why? Because it costs on the average, if you do it old school and you keep the doors heated all the time, depending upon how much you pay for a kilowatt hour, it's anywhere from $300 to $400 per door if per year if these doors are left on 24/7. So anti-sweat modulation, we pulse the anti-sweat based on how humid the store is. Saves a lot of energy. And lighting, again, we do lighting control using the 508 or 512. We can do dimmable, we can do daylight harvesting, we can have multiple zones, all kinds of corporate scheduling capabilities. Again, if your provider it says you have to load shed, we let you choose. First thing I'm going to do is all of the wall sconces go off. Second thing I do is take out all of the mood lighting. Then the third load shed level is I will get rid of 25% of the aisle lights, et cetera, et cetera. And we use an astronomical clock so that we're not relying upon a mechanical clock. And as the daylight, either gets longer or shorter as we move through the system, the astronomical clock makes accommodation for that, also knows when we go into daylight savings time or not. All of that is done automatically.
Charlie?
Yes.
Can we go back to lighting?
Sure.
So as our project, one of them that we're looking to is actually installing the motion sensors to operate the lights. Do you guys, does MicroThermo have any recommendations that are compatible with your MicroThermo?
I can find out for you, Nate. I don't know off the top of my head. If I could ask you to just send me a quick note.
Sure.
Are you going to want it to monitor whether, so you're going to use a motion sensor, and let's say if nobody is in the frozen aisle, all those lights in the cases are going to be off. Do you want to know the status of that switch is either go or no go, right? So you're simply going to want to know the status of that switch, yeah?
Yes, that's right. Like ideally is mainly for night stalking when the night stalkers go in and you know, everything's turned on to either 50% and it wastes a lot of energy, right? So we want to put in the zones. That's why.
Yep, yeah. Send me a quick note on that. And do you know the sensor that you're going to use?
We don't know. I don't know yet. We're still in the sort of feasibility conceptual kind of phase. That's why I'm asking you.
Right.
Yeah,
Nate, my gut reaction would be we would take that as a digital input, right? And we use one of our sensor nodes, which can take a DI input, right? And it's either a 0 or a 1. So we can just keep track of that for you because we have a board that can take many digital inputs, and we just program it. We say, okay, this digital input is coming from the frozen aisle. This is coming from the produce aisle. This is coming from the dairy bossy, et cetera, et cetera. And we're just going to watch it. It's either on or off, on or off, on or off, and we'll keep track of that. We're not doing the control of it. The actual switch is doing the control, but we're just keeping track of that for you.
Yep, that's what we're thinking.
Okay, cool. Yeah, let me know. And then have you met any of my guys in Mirabel, Louis or Michael or any of those guys, Nate?
No, I'm based in BC.
Oh, British Columbia. Okay. All right. So, who do you work with? MicroThermo West?
I actually don't have any contacts. If you can actually forward me any contacts, that'll be awesome because I just got onboarded like 2 weeks ago.
Oh, well, if you who is the gentleman that got us together, Nate?
That'll be my manager, Dudu. He's my manager of the.
Yeah, maybe if you don't mind asking Dudu, like. Who is it that, like, I don't know because I'm in New Jersey, okay, on the East Coast. You're in BC, so I would have no idea. So maybe he can tell you who do you use for installation. I know I have some customers that actually have their own staff, and after it's installed, they take care of it itself. Say again.
We have our own. It's called, I think, display fixtures. That's our own in-house guys to install things.
Awesome. Now, what do they actually do they do the installation on a rehab or a brand new store, or do they just take control after it's built?
Very good question. I actually don't know the answer to that question. All I know is that we do have technicians that go in and examine what's going on. Like for example, we have an alarm on, like, I don't know, the AHU unit. Yeah, we sent a technician over to check it out from DFR.
Awesome. Well, I do know for sure that Loblaws has been a long time user of MicroThermo, and it's good to hear that you have your own your own in-house personnel. I think that gives you the best control of what's going on. That's a personal opinion of me. I always find that the end users who have their own staff like that have a far better and tighter control of what's going on in their store. Okay. Temperature monitoring. Again, we would take that in simply, if it's not a case controller, we would take it in with a universal input. And in that, we can take case temperature. We can also look at defrost termination. We could look at door or jar switches. If there's a pressure transducer, we can take that in. And that type of universal input can live right at the case, or it can live in the chase above the case, wherever you want it to be. And we just run a network wire to it and pick it up. Now, the one thing I do want to talk about with temperature monitoring that we think is still a differentiator for us, Nate and John, is just with one temperature input, we give you the ultimate ability of having 3 different alarms out of one input. So set 1 can be your primary or basic alarm. It could have a very wide berth for the high and low set points. Set 2 can be much, much tighter. You can have a very tight band of high and low set points. And set 3 is the delta or cumulative alarm, and it will look at the difference between set 1 and set 2. This is generally used by people in the United States where food safety and the Board of Health is always in the store. Also, I've done quite a few factories where they process, they make salads and put them in containers, et cetera, and then they have to do reports for the FDA. Also, some pharmaceutical companies, they also have to put reports. This allows them to just dump a report right out of MicroThermo, and they can take a look at how the temperature has behaved, again, for a day, a week, a month, or a year. Now, how we do that is, this is the window that you go in, and here is set 1, here is set 2, and here is set 3. Now, if you look closely with me, set 1 has a high point of 42.8 and a low point of 17.6. But look at set number 2. Now, this triggers at 39. It also triggers at 24. This alarm doesn't have to go to everybody and their brother. It could just go to operation or food quality people. All right? The reason we do this is because with other modalities, here's what happens. I learned this by watching bad technicians. I've got a case or two that is always a problem in the store. How do I solve the problem? I go in, and instead of having this number at 42, I jack it up to 50 degrees. Now I never get an alarm. And you think I did my job well, but no, I didn't. I just put a Band-Aid over this. You're never going to get an alarm, but this could cause a serious food problem in the store by letting this case go all the way to 50 degrees. So that's why, Nate, we talk about individual usernames and passwords. And I'm sure Loblaws probably does this already, but we don't want everybody and their brother going in and messing with these set points. It can cause a serious problem with food quality and bacteria growth, okay? All right? And this cumulative alarm looks at the difference between this and this. Now look at this. Slow me down if I'm going too fast. This is not going to trigger this particular customer if this case has to be at a bad temperature for over 1 hour and 30 minutes before it triggers the alarm. What the cumulative does is for 4 hours, it looks at the difference between 2 and 1. And even if this didn't go off for a whole 1 hour and 30 minutes, but I've had spikes here and there, and those spikes add up and they accumulate to 4 hours, I'm then going to send a food safety alarm so that you know, hey, the prime meats or the aged meat box or the sushi case, even though this alarm never triggered, I've got a cumulative alarm. So let me show you what I'm talking about. This graph here, this is alarm set point 1. Now, you see this, guys? That's my actual temperature. It's not good. It's not riding close to the blue line, which is the set point. And it never turns red. Never turns red because I've never gone outside the parameters. You with me? But 5 minutes here, 15 minutes here, a minute, 5 minutes, 20 minutes, an hour, and finally I've triggered the cumulative. And even though my primary alarm never went off, you see what happened here? My cumulative alarm went off. And you can send that to operations, Nate, or send it to your food quality people, and they know that, hey, even though the case never had a main alarm, I need to get somebody in here. Either I got bad airflow or I've got a coil that's iced up. Something is a problem here, and I've got a cumulative alarm. At this point, we're not aware that anybody out there offers this level of safety as far as temperature. And it's only coming from one temperature sensor. I don't need to have 3 or 4 sensors to do this. Any questions? I hope I'm being clear. Any questions on set 1, set 2, and cumulative alarm at all? Good? Okay, let's go into the nodes themselves. I'm going to go over the 500 and I'm going to go over the 700. Nate, you're going to have a lot of stores with the 500 in it because you've been using MicroThermo for a long time. That's why I want to do this segment here. So the MP500 is configurable. That means I can program it to be an HVAC node, a refrigeration node, a lighting node, an energy node, a VFD node, a chiller skid node, a leak detector node, whatever bloody thing you want it to be, I can make that be that. Here's the one important takeaway that I need you to jot down someplace. One of the reasons, there's 2 reasons why we moved from the 500. We needed to have a more powerful node, and this right here. Because of the way we powered this to take sensor and transducer readings, it required a center tap transformer. I'm going to be honest with you. I've had jobs where the high voltage electrician was being careless, and when they were hooking up to high voltage and a conductor hit one of my boards, smoked the boards, okay? Or smoked the transformer, put the wrong voltage to it. Go out anywhere in the United States at least and try to find a center tap transformer. It's going to require you to call MicroThermo and get us to send you a center tap transformer. Nate, I don't know, you're an electrical engineer, correct?
Yep.
Do you know, is it common in Canada? Are center tap transformers readily available at your normal local supplier right down on Main Street?
I do not know.
Okay.
Because then I did system design, and no, we don't really. No, I've never really had like yeah, I never encountered problem have to ordering like a center tap transformer or anything like that.
Well, just know that the 504, the 500, the 504, the 508, and the 512 must be a 24-volt center tap transformer. Okay. And it is a problem in the United States. They're not readily available. So that's my segue into why we went to the 700. Now, they all have 8 universal inputs. They all have low-pass filters for protection. And They are actually a smart node, or think of it as a microcomputer. This side of the board here, gentlemen, that's the smart side. This is the business end with all of the switches and the inputs, but this is my brain right here. That's why I don't have a master controller. Once I program this, if I say you are taking leak detection, you are controlling a rooftop, and you are controlling 12 fans and a condenser, once I tell this smart node what it is what it is. It is what I told it to be, okay? I don't need that data logger in there to tell this 512 what to do, because it has a neuron, a transceiver, logic, and memory on board, okay? Everybody with me on that? Where do they get their names? The 504, 4 relays. The 508, 8 relays. The 512, 12 relays. They all have 8 universal inputs. They all have 4 analog outputs, which are configurable. The adder on the 508 is we have enough space to give you 4 digital inputs, and the 512, we have the space on there to give you 8 digital inputs. And again, that could be a light switch that goes on and off, could be a door switch, whatever it needs to be. Any questions on this at all? Okay, moving on. The other dedicated smart nodes, Nate, that you will see, your legacy stores, every compressor had its own compressor node. That made the compressor smart even before compressor manufacturers started making smart compressors. We also had the circuit control board for every refrigeration circuit that you had, EPR controller, and I've already talked about the alarm node. That's the base alarm node. Remember I said this was a compound, and this is the piggyback node. Real-time clock goes here, schedule number 1 goes here, schedule number 2 goes here. So again, that's the smart section, that's the smart section, that's the smart section, and that is the smart section right there, okay? There were limitations to this design, and another reason why we went to this 700 is I want you to know it makes us much more flexible, and it requires a lot less nodes. Being perfectly honest with you, the customers have told me, Charlie, I love your product, but man, you use a lot of nodes. So we found a way to reduce the amount of nodes and give you more power, which I'm going to talk about in a little bit, but that's where that was the genesis of the 700 series. All right. The EPR board here is kind of a crossover. This was a transition that led us to what we can do with the 700 node. Here's what we were able to do. We were able to control 1, 2, 3, 4, 5, 6 steppers, CDS valves, CDS 9, CDS 16, CDS 17. We can control 6 CDS stepper valves or electric EPR valves out of this one node. We were able to set it up for either single or dual temp. The biggest thing that I want to talk about is that we were able to put an intelligent algorithm into that which controlled the valve position based on evaporative load, sensible load, predictive load, liquid temperature, and the environmental conditions in the store. And we were also able to tell one of the EPRs to be priority, and the other ones were energy savings. Okay? Any questions about that at all? So here's what we started to pack into there. So whether it was a CDS 4, 7, 9, 16, or 17, we didn't go with the catalog value of the valve. We actually tested each and every valve, and we shaped the control of that based on the actual output of the EPR, which meant we weren't controlling to a theoretical capacity. We are controlling to an actual flow capacity. All right. Again, that enables you to get your money's worth. You're paying for electronic control. Let's not control to what we think is happening. Every valve, whether it's a 4, 7, or 9, has a characteristic. It has a flow curve. And what we did is we programmed in every single data point and we control to that curve, which increases the accuracy of temperature and pressure, astronomically. What can we do? I said we could do 6 EPRs. One of them could be priority. We can optimize it. Is it a dairy case? Is it a produce case, etc.? We can delay opening on startup so that when we turn the store on, we don't blast the valves wide open. We gently ramp them up so that we're just not sending a boatload of load to the compressor rack. We can also tell them to be delayed after defrost. Why do we do that? Well, if 2 circuits come out of defrost, that's a massive load that we're sending down the line to the mechanical room. That might cause extra compressors to kick on, okay? Why make all 6 compressors kick on if I can slightly feather those EPRs gently back in, and I can then still hold it with only 3 or 4 compressors running rather than have all 5 or all 6 compressors. We also do pressure drop correction and flow correction depending upon how the valve is physically piped. We took everything that we learned from the electric EPR and we put it into the case controller, which was one of the first MT700 boards. Now, like Dave asked a question earlier, this is a compound node. If I take the cover over this, you will see a base node and then you will see a pedestal node. So this is a compound node. It was originally designed for CO2 8 years ago, but we quickly made it that it can control any of the current refrigerants that are out there, not just CO2. It does smart fan control, a true pressure temperature superheat control, and also case temperature control. There's 4 modalities to this. We can do superheat control with temperature backup. We can do temperature with superheat backup, or we could do pure superheat control or pure temperature control. Okay, so let me say that again. Temperature with superheat backup, superheat with temperature backup, pure temperature control, or pure superheat control. So we can program it either way you want it, okay? The cumulative alarms that I told you about, set 1, set 2, and cumulative, we put that's featured in the case controller. And everything we learned from the EPR, the case type, delaying after startup, all of that. Everything we learned from the EPR, we put into the case controller. I've already got ahead of myself. These are the ways that we control the case controller. And trend graph is in there. We optimize it by fixture. We optimize it by valve type, base value correction, maximum percentage open. What do I mean by that? After I start a store up, Nate, if I go into a case and I see that valve never, ever, ever goes past 38%, ever. Well, why should I let the maximum be 100%? I'm making the valve operator stroke more than it needs to when it opens up. So I can make the maximum opening 38% because I know, I looked at it. I looked at the graph for 3 weeks. It never goes past 38%. I'm going to make that my maximum. If it's not getting down to temperature fast enough, I can do pull down correction. Delayed opening after defrost. Liquid temperature correction. Why do I use that? Low temp cases, subcooled. I find out after I build the store that I really have 50-degree liquid coming to this case. Or conversely, I find out that my subcooler is not operating as well as I thought, and I designed my store with a 50-degree liquid input, but by actual measurement on the job site, the best I can do is 65-degree liquid coming to that case controller. I can correct for that. You can't do that with a mechanical expansion valve. You can do that with a case controller and a stepper valve. pressure drop correction. Okay, is this case 500 feet away from the rack? Yeah, there's going to be a difference in pressure drop going across that valve. Flow correction, based on whether the flow is coming in axially or radially, and then ambient correction. Not everybody uses this, and I wish they would. If it's February and the store is 72 degrees, but it's at 42 relative humidity, that's different than if it's August and the store is in Louisiana and it's 76 degrees and it's 60% relative humidity. The load on that, especially the latent load, is going to be different than it is in January and February. If you energize ambient correction, it'll take that into consideration and control that case even tighter for you. And again, just like the EPR, whether it's the 1.5 all the way to the 175-ton valve, we've shaped all of the flow profiles. So when you do the drop down, guys, it tells you, it gives you a list. What valve are you using? I'm using a AA. I'm using a D. I'm using a C. I'm using a J. That drop down is in there. And what that does is it tells the computer, okay, this happens to be an SER6. Look at that. Here's the catalog value, but here's what the valve actually does. It overperforms. It actually gives you more capacity than what is stated under standard conditions. So we can control to the blue line, not the red catalog line. And there's the case controller for you. Just like a mechanical valve, we're taking a true pressure temperature superheat. At the same time, we can take a look at the temperature coming off the coil. Also, when it's time to defrost, certain manufacturers tell us this probe has to go at this spot because we know this spot gives us the best reference for defrost termination. So we have a defrost termination sensor, and we do have space on here for a fourth temperature if you want to do product simulation temperature. If it is required in your locality, we have a fourth auxiliary input where you could do a product temperature input. So not only do you have the superheat, not only do you have the temperature coming off the coil, not only do you have temperature defrost termination, but you've got the simulation temperature, okay, for that case. Any questions on this at all? Oh, also built in is a solid state relay that will control the heavy duty solid state relay. And this is how we pulse the anti-sweat. So if it's very dry and the anti-sweats only have to be pulsed 10%, we're going to pulse this switch 10%. If it's extremely humid and we need to have the doors active 60 or 70% of the time, we're going to pulse this fast acting switch. So that 70% of the time, or say 7 out of 10 seconds, this switch is going to be active, and we're going to be heating the glass and heating the door frame. And that's all coming right out of the case controller. The other thing with the case controller, it allows you to save money on wiring because you run your input voltage to the case controller, and we're controlling the lights and the fans and everything right out of the case controller. So it cuts wiring costs down. Questions? And here's what I meant about the ambient condition. If we're controlling, even if we're not, but if we're controlling HVAC, depending upon the size of the store, we might have 1, we might have 4 store ambients. You know, northeast, southeast, southwest, northwest, and depending upon where the cases are, we tell it to take a look at the temperature and the humidity, and we take that as an input to the EEPR board or to the case controller. And we're going to change the way we do that control based on the ambient conditions. And again, it makes it more accurate. This is the process tab of the case controller. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tabs in here. Okay, so when I call this a compound node, it's not only because of the board and the pedestal board that's in there. It's because of the unbelievable amount of logic and algorithms that's built into this board. There's a ton of communication going here. So this is your process. This is going to be your landing view. It's going to tell you if it's this type of case, are the lights on or off? Is the door open and closed? How many percent open is the valve? Is the fan running? What's my temperature? What's my calculated superheat? If I want to do trend graphs, here's my button right there. I can do trend graphs right from there. What else is in here? Here's your system tab, which sets up the lineup. Do I have 1, 2, 3, 6 cases in the lineup? What circuit am I coming out of, et cetera, et cetera. The next tab is configuration. Here, this is one that's set up for temperature control with a superheat limit. Fan is coming off of relay 1. Where am I getting my lighting and other information from? Am I getting it from a local on board, or am I getting it from one of the schedulers? Where are my lights coming from? Relay 3. Anti-sweat, am I using it? Yes or no? So here's where I do a lot of the virtual configuration of the board. Do I have a clean switch? Okay, or do I have a software clean switch? The next tab is all my inputs and outputs. Temperature 1, 2, 3, 4. Am I using digital input 1? Am I using digital input 2? My environmental variables, am I using them? Yes or no? Where are they coming from? Guys, slow me down if I'm going too fast. Here's my valve. Here's the drop down. I've chosen that as an SERC, and I've chosen that the flow is axial, meaning that if you looked at this as a gyroscope or a spinning top, it's coming in on the axis. If it was coming in on the side, it would be coming in on the radius. That's why we call it radial. But guess what? It makes a slight difference on the capacity of that valve depending upon how it's piped. And we can make a correction. We can also do a calibration correction. All right. Any questions on this at all? Okay, here's my alarm. Now in this store, they're only using set number 1. This is where I set my high limit, my low limit. Here's my initial time for the high, my initial time for the low. This is not fully programmed. And here's my recall time. All right. And if I had a set 2, it would appear here. If I had a cumulative alarm, it would appear here. Also, I enable the superheat alarm. I could enable a door ajar alarm. I can enable a sensor failure alarm, missing defrost data, missing net refrigeration data, missing environmental data. Why would I have this? Let's just say somebody is doing something on the HVAC system and they disconnect the node that's taking the temperature and relative humidity for the store, and my case controller is looking for that as an input, and suddenly that input disappears, okay, it's going to get an alarm. Here's my control tab. Now look at this. Inside the control tab, I have a valve, a superheat, a pull down, a temperature control, an environmental, defrost. I have set points or algorithms for that type of control. This all gets to this. This is the takeaway of what all that means, and that's an awful lot to throw at you. But if you're going to use MicroThermo case controllers, and we want you to use them, we want you to get your money's worth. This green line here, that's the actual temperature. You can't see the blue line behind it, but take my word for it, that's the set point. It's hardly visible because my actual operating temperature is right above it. Now I go into defrost. You see how high my temperature spikes? I come out of defrost and boom, I drop like a rock. Why? Because I've tweaked my pull down setting to get a super fast pull down, yet I never blow past the set point and trigger a low temperature alarm. So that is what you want to see. And Nate, that's what you want your guys to take a look at, or you want your installing contractors to do everything properly, because if you're making the investment on electrical control, computer control, and I pulled this from a store, by the way. This is not a mock. This is an actual graph I pulled from one of my customers roundies, okay? Those are actual temperatures. That's what you should get when you set up a case controller properly. Any questions? All right, the other 700 series that we have, the first one we came out with was the monitoring node. And what I want to point out here is in about the same space as a 504 that could give me only 8 universal inputs, I now get 18 universal inputs out of this, okay? But here's the big takeaway, 24 volts AC. It is a standard transformer that you can get out of any electrical or refrigeration supply store. That it no longer has to be center tap. Okay, moving on. The initial one, the brain, was a 722A. The newer version uses an even more powerful brain, the 722F. The 700 series allows you to mix and match. Here is a 722F with a 748V, meaning I can drive 8 valves out of this. But it's even more flexible than that. I can use a 748A, or I can use a 708R, which is 8 relays. Again, I can mix and match, and I can have a train, a total of 10 nodes all together on one train. That is how powerful. Stay with me. I hope I explained this. Remember I showed you on the old school 500 boards, the smart side of the board? This 722F takes the place of the smart side of that smart node. But it is so powerful, I can do a train now that's 10 nodes long. And I can mix and match it. It could be 24 EEPRs, 160 relays. I can do case controllers. I can do temp EPRs. I could do it as a circuit pressure regulator. I could use it to control the rack. I could use it to control the condenser or gas cooler. It's truly super, super flexible. And the other big takeaway I want to tell you about is it takes way less physical space, but here's the even better thing. Getting the store program integrated and up running, if this train was 10 units long with MicroThermo 500 series, I'd have to integrate 8, 9, or 10 nodes. With the 700, this brain is so powerful that it controls the other nodes plugged into it. Guess what? It only requires one network connection, not 8, not 10, and the service button is right here. Once I service pin this, which is what we call integration, and it handshakes the physical node to the virtual node, and all of the programming and set points drop in. Are you with me? Now, by doing just one node, guess what? I program and integrate all 6, 7, 8, 9, or 10 of these nodes. So, less wiring. Now I only have to run power to one node, not 10. I only have to run network to one node, not 10. And when I hit a service pin, I only have to service pin 1 and not do it 6, 7, or 8 times. So that's why it went to the 700. So Nate, your newer stores, you're going to see more of the 700. Okay? I think I heard a question.
No, I was just saying that's nice. Charlie, can these be mixed and matched with the 500s on from the same data logger?
I have stores now that have, let's say they've added 20,000 square feet to it, and the first part of the store is 500s. The new part of the store is 700s. Yes, my brother, they can work on the same data logger, but you might find that the data logger might have had version 5 or version 6 or version 7. We're now up to version 8.1 or 8.2. The only thing we have to do is just do a quick upgrade that takes about 2 hours. We upgrade the data logger to the new Alliance version. Now I can have 500s and 700s running together.
Okay, nice.
Yeah, and we did that because with other manufacturers, John, when they upgrade, they go, yeah, sorry, we don't support that product anymore. Nah, you can't use it. And then the customer winds up with tens of thousands of dollars of hardware that has now just become instantaneously obsolete, we don't play that game. Okay, so you can have stores, half of it is the original, part of the store. It's got 500s in it. Just upgrade the PC, and then you can have the new part of the store using the 700 nodes. Okay.
Nice.
All right. So again, just to show you, now I mentioned about every compressor, old school, had to have a node. Now I control the rack. Guess what? The train is usually only 4 or 5 boards long to control a rack. All right. So that, again, this is a huge step forward for us when we went from the 500 to the 700 series. That brain is so much more powerful. It takes a lot less nodes physically installed, a lot less network wiring installed to make everything work. Just a little bit. Nate, are you guys, again, pardon me for not knowing this, are you guys doing transcritical CO2?
Oh, I don't think so. I haven't seen that before.
Okay, I'll just make this brief to let you know we do have the capabilities for transcritical CO2. We have nodes specifically designed for the DT set cool for CO2 and CO2 defrost, the gas cooler node, the flash tank controller, case controllers, as I mentioned before, for CO2. The biggest difference with CO2, Nate, to keep it simple, is this right here, okay? Old school, you would call this a receiver, and we'd always have a certain amount of liquid refrigerant in the receiver, all right? With CO2, if it gets warmer than about 83 to 86 degrees, and I'm condensing 10 or 20 degrees hotter than the ambient, the CO2 crosses the critical point, okay? And it becomes an undefined fluid, all right? Still very damn powerful, but it's an undefined fluid. And no matter how many fans, I could have 100 fans in the gas cooler, I can't get it past, I can't get it to get below the critical point again. So that's where this valve, and this tank come into consideration. To make it get back down to CO2, which is 100% liquid, I have to play games with the temperature and the pressure. So this is more than a head pressure valve. I'm controlling what's happening on the drop leg. You with me on this? At the same time, this line here is going to one of the racks, and this tank is constantly under the suction of another rack in the store. You with me? So I'm drawing down on this tank. Why am I doing that? Between this valve here and this valve here, I'm playing games with the environment inside the flash tank. So if that CO2 has gone past the critical point and has now become transcritical, now I can get it below the critical point and get all of the CO2 back to 100% liquid and as much subcooling as I can get out of it, okay? It's not going to be as deep as regular systems, let's say 404A, where you might have 7, 8, 10, 12 degrees of subcooling. You're doing well if you can get 2 or 3 or 4 degrees of subcooling with CO2, but generally it's good. But that is beside it being higher pressure, this is where the magic happens between these two valves and what's happening in the flash tank here. And we were one of the first people to come out with a controller to do this, okay? Any questions at all? And again, this is the controller that we use for those two valves. It's a 722F, and it's a 2-valve controller. And what we do is we seesaw or feather those valves back and forth, so we can just open and close these as needed to make the conditions in the flash tank perfect. Okay? And then lastly, remote control. I'll make this very brief. Nate, you told me that you're using a VPN. A lot of customers use VPN. Just so that you know that every MicroThermo unit does come with a resident Team Viewer program on there. Team Viewer is a 128-bit encrypted, and it goes through an external firewall. It can also go through a firewall that the customer has. And what that does, it completely keeps it off your local area network, and it allows you to have access to any one of the stores. There is an ability to use TeamViewer and VPN together. Again, I'm not familiar with how we are remote communicating. That's something you're probably going to want to check into. But TeamViewer is an application that you can get on the Apple Store, the Google Store, or the Android Store, loaded into your phone, and you could look and operate the store right from the phone, just like you were standing in the store. And it's encrypted, as I said, and you also have to have a TeamViewer identity and a TeamViewer password. So you're challenged on the MicroThermo side. You need a username and a password. You also need a username and password for TeamViewer, okay? And again, just wrapping it up, depending whether you use VPN, it is possible, or TeamViewer, you have full access to MicroThermo in any of the windows, whether you're using desktop, laptop, tablet, or smartphone. We're coming up at 3 o'clock, which is the end time for the class. I hope I didn't make this too long. I wanted to try to go over as much as I could in one class. Maybe, again, if I can get permission from a store chain to be allowed, it would be good if I could maybe just spend a quick 30 minutes with the same group again, and we'll actually interrogate a live store, and I can get into the guts a little bit deeper than you can with a PowerPoint presentation. I'm sorry to say, Nate, I haven't figured out a way either with VNC or VPN to get either Google Meet or TeamViewer, or no, TeamViewer will work, but Google Meeting or Zoom doesn't seem to work with a VPN, I'm sorry to say, okay? All right, before we say goodbye to each other, any questions at all?
Pretty good. So I will send you an email in regards to your recommendations for motion sensors, because that is something we're looking into.
Okay.
Other than that, thank you.